Hello again, it's time for lesson 13.3, quotient of powers property. So we've talked all about product of powers properties, and now it's division's turn. Division has taken over today. So you have previously learned that when you're multiplying powers with the same base, you bring over the base and you add the exponents. Now I'm going to teach you how to simplify expressions where you are dividing the same base. And it's not in simplest form because you can't have the same base being repeated in an expression. So basically our goal, we want to be able to rewrite these types of expressions as a single base and exponent, as a single power. So the rule is to divide powers with the same base, all you need to do is bring over the base and subtract the exponents. And order does matter when you subtract, so we're always going to take the numerator minus the denominator, exponent-wise. So 4 to the 5th divided by 4 squared is the same as 4 to the 5 minus 2, or third power. And of course I want you to see why it works so that if you forget the rule, you have a go-to. So here's how it works and why it works. 4 to the 5th power, we know that that means the same as 4 times 4 times 4 times 4 times 4, right? That exponent tells me I have 5 4s. And in my denominator, 4 squared would mean 4 times 4. Now, I'm sure you recall simplifying fractions. We did some cross-canceling, different things like that. But I know that if I have a number divided by itself, it's 1, right? So 4 divided by 4 is 1, and 4 divided by 4 is 1. And how many 4s do I have left after those have canceled, or divided out to be 1? Yep, 3. So instead of writing all of those out, you can just simply remember, oh yeah, I end up canceling 2 of those 5 out, because when you divide a number by itself, you get 1, and 3 are left. So let's try a few of these. Let me zoom in a little bit. This first one. Okay, so we're going to simplify each expression. We're not going to actually solve out. We're not going to evaluate. I just want us to simplify. So always make sure you're paying close attention to those directions. So I see I have the same base. It's being divided. So 2 to the 6th power divided by 2 to the 4th power. And yes, for the first one, I do want you to write this. We're going to bring over the base, and we're going to subtract our exponents, top down. So 2 to the 6 minus 4 is 2. So 2 to the 6th divided by 2 to the 4th is equivalent to 2 squared. It's really that easy. Crazy, I know. Go ahead and circle that. All right, next one, I have the same base being divided, so I'm going to bring over the base. It's the quantity of -7. And I have a 9 and a 3. Well, 9 minus 3 is 6. It's that easy, my friends. I know. I love this property. Okay, same base. I'm going to bring over the base. Subtract my exponents. 8 minus 5 is 3. Go on to the next one. I see that I'm dividing that same base. I will bring over my base. And 8 minus 4 is 4. Done. All right, next one, of course, it's got the y without the exponent. A lot of people want to say, well, bring over y, and 10 minus nothing is 10, so y to the 10th. This isn't y to the nothing. This is really y to the 1st power. So y to the 10th divided by y to the 1st is really y to the 9th. Last but not least, I have p to the 8th divided by p to the 7th. Bring over the base. 8 minus 7 is 1. And if we are writing this in simplest form, any number to the 1st power is itself, so your answer should just be p. I know, crazy. All right, now I want you to be able to go a step further here, and I'm going to add kind of a little bit more to it. So I want you to simplify these exponential expressions, simplify these powers, and within these, you'll end up using your product and quotient rules to simplify the expression. So I guess you're just applying things you've already learned, but there are a few different ways that you could do this. So in looking at this, I see here in the numerator I'm multiplying the same base, but I also see I'm dividing the same base. What I would recommend that you do is take care of the numerator, take care of the denominator, and then simplify. Meaning, let's just look at the top part right here. I have 3 to the 4th times 3 squared. You learn that when you multiply expressions with the same base, you can bring over the base and add the exponents. So 3 to the 4th times 3 squared is equivalent to 3 to the 6th power, right? That's my numerator. My denominator is still 3 to the 3rd. Now I can go ahead and use my quotient rules. We just learned that when you divide expressions with the same base, you bring over the base and subtract the exponent. 6 minus 3 is 3. Now, there are a few other ways that you could attack these problems. I'm not going to show you every single way, but in class we'll explore a few different ways and you can find what way you like the best. All right, scooch it on over. Here we go. I have x to the 15th over x to the 3rd times x to the 5th. Again, I highly recommend you simplifying the top and simplifying the bottom. So the top, the numerator is already simplified. If you're looking just at the bottom, this is x to the 3rd times x to the 5th. When you're multiplying the same base, bring over the base, add the exponents. So x to the 3rd times x to the 5th is equivalent to x to the 8th, and now we can go ahead and use those division rules. When you divide the same base, bring over the base, and subtract your exponents. 15 minus 8 is 7. So this would simplify to x to the 7th power. Right, in the next problem, now this time I don't have it written all of one big line, but it's the same concept here. If I'm multiplying fractions, but these are fractions, you multiply across the top, you multiply across the bottom, and you simplify. So let's do that. If you take a to the 10th power times a to the 7th power, bring over the base, add your exponents. Same thing here, a to the 6th power times a to the 4th power, bring over the base, add the exponents. So I have a to the 17th over a to the 10th. Now I can use my quotient rules. I'm dividing the same base, bring over the base, and just to let you know, every time I say the word base, I have the song in my head. I don't know if you do too, but you're probably going to be so sick of hearing that song by the end of this chapter. We can have a celebration when it's done. Anyway, 17 minus 10 is 7. So for this one, a to the 7th power represents this same exact thing. They're worth the same amount. This is simplified. Last but not least, m to the 5th times m to the 9th. Bring over the base, yep, and 5 plus 9 is 14. On the bottom, I have m times m to the 8th. Remember, this m really means m to the 1st power. Bring over the base, and 1 plus 8 is 9. And now, yes, I'm dividing the same base, so you can bring over the base, and 14 minus 9 is 5. That is it for today. I will see you tomorrow.